Right now, as you settle into this quiet moment, your heart is beating. Your lungs are filling and emptying with air. These rhythms feel like the truest measure of time you know. But tonight, we're going to discover something wonderful. Something that might change how you think about every second that passes. Your body has always been your personal timekeeper. When you were small, you measured minutes by how long it took to tie your shoes. You counted hours by meals and naps. You learned that days begin with sunrise and end when stars appear. This feels natural. Right. Like time should flow the same for everyone, everywhere. Close your eyes for a moment. Feel your pulse in your wrist. Count 3 heartbeats. 1, 2, 3. Those 3 beats just happened in what we call 3 seconds. But here's the secret the universe has been keeping. Those same 3 seconds don't happen the same way everywhere. High above your head, time moves a little faster. Deep below your feet, it moves a little slower. The difference is tiny, like the whisper between raindrops. But it's real. This isn't magic. It's not make-believe. It's one of the most beautiful discoveries humans have ever made about the world we live in. Imagine time like a river. You've always thought rivers flow at the same speed everywhere. But rivers flow faster in some places and slower in others. They rush over rocks and pool in quiet bends. They speed up when the banks narrow and slow down when they spread wide. Time flows like this too. It moves differently depending on where you are and what's around you. The earth beneath your body right now is pulling on you. You can feel this pull as weight. When you lie down, you sink slightly into your mattress. This same pull that makes you feel heavy also makes time move just a tiny bit slower. It's as if the earth is gently holding on to each second, asking it to stay just a moment longer. Think about this. Every breath you take happens in Earth time. Every heartbeat follows Earth's rhythm. You are living inside a bubble of time that's shaped by the planet beneath you. But what if you could travel? What if you could visit places where time flows differently? Deep underground, in caves that stretch far below the surface, time moves even slower than here in your room. Not by much. Not in a way you could feel. But enough that the most careful clocks in the world can measure it. High up on mountains, where the air grows thin and the Earth's pull grows weak, time moves faster. Again, just by tiny amounts. But it moves faster nonetheless. And far above, where satellites circle the planet like metal moons, time flows faster still. This means something incredible. If you had a twin, and that twin lived deep underground while you lived on the surface, you would age at slightly different rates. Over many, many years, there would be a difference. Microscopic. Invisible to your eyes. But real. The universe keeps time in ways your body cannot feel. But science has learned to listen to these cosmic rhythms. We've built clocks so sensitive they can hear time's heartbeat changing with every step up a staircase. These discoveries started with one man's imagination. A man who wondered what it would be like to ride alongside a beam of light. His wondering led to equations. His equations led to predictions. And his predictions led to one of the most amazing truths about reality. Time is not the steady drumbeat you thought it was. It's more like music. It has tempo changes. It has quiet passages and crescendos. It bends and flows and dances with everything around it. You are part of this cosmic symphony right now. Your heartbeat keeps time with Earth's rhythm. Your breathing follows the tempo of gravity itself. When you sleep tonight, your dreams will unfold in Earth time. The neurons in your brain will fire in patterns shaped by our planet's gentle hold on every passing moment. This is your first glimpse into a deeper truth about existence. Time is not separate from space. It's not separate from matter. It's woven into the very fabric of everything that is. As you rest here, feeling your pulse and listening to your breath, you are experiencing time the way it flows in your exact spot in the universe. No one else, anywhere, experiences time in quite the same way you do right now. Tomorrow, when you walk upstairs, you'll be moving into slightly faster time. When you go into a basement, you'll enter slightly slower time. These changes are too small to notice, but they're as real as the ground beneath your feet. The universe is full of places where time behaves in ways that would amaze you. Places where seconds stretch like taffy. Places where minutes race like swift streams. Tonight, as sleep begins to find you, let your mind wander to a man with wild hair and kind eyes. A man who first imagined that time could bend and flow like water. His name was Einstein, and his gentle revolution changed everything we thought we knew about the rhythm of existence itself. Picture a young man sitting by a window, watching sunlight stream through the glass. His hair curls in every direction. His eyes hold the kind of wonder you see in children discovering snow for the first time. This is Albert Einstein. And he's about to ask a question that will change everything. What would it feel like, he wonders, to ride alongside a beam of light? Close your eyes and imagine this with him. You're moving as fast as light itself. The world around you would look strange. Time would behave in ways no human had ever dreamed possible. Einstein didn't just wonder about this once and forget it. He carried this question with him like a smooth stone in his pocket. He turned it over and over in his mind. He let it grow and change and lead him to other questions. What is light, really? What is time? What is space? For hundreds of years before Einstein, people believed time was like a great cosmic clock. It ticked the same for everyone, everywhere. A second on Earth was the same as a second on the Moon. The same as a second anywhere in the universe. But Einstein's imagination saw something different. He realized that space and time are not separate things. They're woven together like threads in a blanket. When something happens to space, something happens to time too. They move together. They bend together. They dance together. Think of a trampoline stretched tight and flat. This is how people used to picture space. Empty. Even. The same everywhere. Now imagine placing a heavy ball in the center of that trampoline. The surface curves and dips around the ball. The fabric bends. This is what mass does to space. Every planet, every star, every grain of sand creates curves in the fabric of space itself. And where space curves, time curves too. Einstein called this curved fabric spacetime. One word for two things that cannot be separated. You live inside curved spacetime right now. The Earth beneath you is like that heavy ball on the trampoline. It bends space around itself. And in that bent space, time flows differently than it would in empty, flat space. This bending is so gentle, so subtle, that your body cannot feel it. But it's there. Always. Shaping every moment of your existence. Einstein worked out the mathematics of this idea. Numbers and symbols that described how mass and energy curve space-time. How this curving affects the flow of time itself. His equations were beautiful. They were elegant. But were they true? The first test came during a solar eclipse. When the moon passed in front of the sun, astronomers could see stars that were normally hidden by sunlight. Einstein predicted that the sun's gravity would bend the path of starlight. The stars would appear to be in slightly different positions. On that day, when the eclipse darkened the sky, observers looked through their telescopes. And there it was. The starlight had bent, exactly as Einstein predicted. Space was curved. Time was flexible. The universe was far stranger and more wonderful than anyone had imagined. But Einstein's revolution went even deeper than bending starlight. He discovered that nothing in the universe can travel faster than light. Not rockets. Not radio signals. Not even information itself. Light speed is the universe's ultimate speed limit. This creates something magical. When objects move very fast, time slows down for them. When objects feel strong gravity, time slows down for them too. These aren't separate effects. They're two faces of the same cosmic truth. Motion through space and the pull of gravity both curve spacetime in ways that change how time flows. Imagine you're on a train moving close to the speed of light. To you, inside the train, everything feels normal. Your watch ticks normally. Your heart beats normally. But to someone standing on the platform, watching you pass, your time appears to be moving slowly. Your watch would seem to tick slower. Your movements would seem dreamlike and stretched. This isn't an illusion. It's not a trick of the eyes. Time really is passing differently for you than for the person on the platform. The same thing happens with gravity. The stronger the gravity, the slower time moves. The Earth's gravity is gentle compared to other objects in space. But it's strong enough to make time run slightly slower here than it would in the empty space between stars. Einstein realized that gravity and acceleration feel the same. If you're in an elevator with no windows, you can't tell if you're sitting still in Earth's gravity or accelerating upward through space. This insight led him to understand that gravity isn't a force pulling on you. It's the curvature of spacetime itself. You're not being pulled down toward the Earth. You're following the straightest possible path through curved spacetime. It just feels like falling. This gentle man with wild hair had imagined his way to truths that seemed impossible. Time could slow down. Space could bend. Mass could curve the very fabric of reality. His ideas frightened some people. They seemed too strange, too far from everyday experience. But experiment after experiment proved Einstein right. Today, his discoveries help guide spacecraft to distant planets. They keep the satellites above your head running on time. They make possible the GPS that knows exactly where you are on Earth. Einstein's gentle revolution touches your life in ways you never notice. Every time you use a cell phone or check a map on your computer, you're depending on his insights about the dance between space and time. As you rest here tonight, you're experiencing Einstein's universe firsthand. Time flows around you at Earth's rhythm. Space curves gently beneath your body. But there are places in the universe where Einstein's effects become much stronger. Places where time moves so differently that seconds stretch into hours. Where gravity bends spacetime so sharply that even light cannot escape. Tonight, though, we'll explore somewhere closer to home. Somewhere you could actually visit, where time's gentle dance becomes just a little more noticeable. Right now, as you lie still, something invisible is touching you. You've felt it your entire life, but you've never really noticed it. It's so constant, so gentle, that it feels like part of you. This invisible touch is gravity. And it's doing something remarkable to time itself. Feel your body pressing into the surface beneath you. This gentle weight you carry is your connection to something vast. Every atom in your body is responding to every atom in the Earth below. The planet beneath you contains more matter than your mind can truly grasp. Rock and metal, water and soil, all pulling softly on every part of you. This pull creates your weight. But it also creates something else. It creates a conversation between mass and time. Imagine time as a river flowing past you. In empty space, far from any stars or planets, this river would flow smooth and even. But here, near Earth, the river flows differently. The planet's mass reaches out like invisible hands, gently slowing the current of moments. This slowing is so small you could never feel it. But it's real. Measurable. As constant as your heartbeat. Every piece of matter in the universe does this. Your coffee cup slows time by a tiny amount. Your cat, your car, your house. Even your own body creates the tiniest change in how time flows around you. But these effects are whisper small. To notice gravity's touch on time, you need something much more massive than everyday objects. The Earth is perfect for this. It's big enough to create a noticeable effect, but gentle enough that you can live comfortably in its embrace. Think about a mountain. Not just any mountain, but the tallest one you can imagine. Its peak reaches high into the thin air, while its base spreads wide across the landscape. At the bottom of this mountain, you're closer to most of Earth's mass. The pull of gravity is slightly stronger here. Time moves slightly slower. At the top of the mountain, you're farther from Earth's center. You're also farther from all that rock and metal below. Gravity's pull is slightly weaker. Time moves slightly faster. The difference is incredibly small. If you lived your whole life at the top of a mountain, you would age only microseconds more than someone who lived at sea level. But those microseconds are real. They can be measured. Scientists have proven this by carrying the most precise clocks in the world up mountains and down into valleys. These clocks are so sensitive they can detect changes in time that last less than a billionth of a second. When they bring a clock up a mountain, it starts running faster. When they take it down into a deep valley, it starts running slower. The clock isn't broken. Time itself is flowing at different rates. This means something beautiful and strange. Your head experiences time slightly differently than your feet. The difference is unimaginably small, but it's there. Your head is farther from Earth's center than your feet. It feels slightly less gravity. Time flows slightly faster for the top of your body than for the bottom. You are a living, breathing experiment in how gravity shapes time. But Earth's gravity is gentle compared to other objects in space. There are places in the universe where gravity's touch becomes so strong that time nearly stops. Near black holes, where matter has collapsed into points of unimaginable density, time slows to a crawl. What feels like minutes near a black hole would be years to someone far away. But we don't need to travel to black holes to see gravity's effects. They're happening all around you, in ways that touch your daily life. The satellites orbiting high above your head experience weaker gravity than you do. Time flows faster for them. If their clocks weren't constantly adjusted for this difference, your GPS would become lost within hours. Every day, these satellites have their clocks reset to account for the time difference created by gravity. Without this correction, the location on your phone would drift farther and farther from where you actually are. This is Einstein's universe in action. His insights about gravity and time make it possible for you to know exactly where you are on Earth at any moment. Deep underground, in caves and mines, gravity's touch grows stronger. Miners working far beneath the surface experience time moving slightly slower than people on the surface above. Not slower in any way they could feel. Their hearts beat normally. Their thoughts move normally. But the flow of time itself is different. Ocean trenches create the same effect. In the deepest parts of the sea, where water presses down with enormous weight, and where the seafloor sits closest to Earth's dense core, time moves at its slowest pace on our planet's surface. The creatures living in these depths experience a subtly different rhythm of existence than the birds flying overhead. Even in your own home, gravity creates tiny differences in time's flow. Your basement experiences time slightly slower than your attic. The difference is far too small to matter in daily life, but it's measurable with the right instruments. Water flowing downhill moves from slower time to faster time. Every waterfall is a gentle transition between different rates of temporal flow. The tides that rise and fall in Earth's oceans are also rising and falling through gradual changes in time's rhythm. All of this happens because mass and time are connected in ways that seem magical but are deeply natural. Every piece of matter in the universe participates in this cosmic conversation. The more massive something is, the more it slows time around itself. The less massive, the less effect it has. But everything participates. Nothing is excluded from this dance. As you rest here, your body is part of this ancient rhythm. Every breath you take happens in Earth time, shaped by the planet's gentle pull on each passing moment. Your dreams tonight will unfold in time that flows at Earth's pace. Your cells will divide, your heart will beat, your thoughts will form, all following the temporal rhythm created by the mass beneath you. This is why time feels so natural to you. You've never known any other rhythm. Earth's gravity has been shaping your experience of time since the moment you were born. But somewhere beneath your feet, in places carved by water and darkness, time moves even more slowly than here beside your pillow. Imagine walking through a forest until you find a small opening in the hillside. The entrance is just wide enough for your body. Cool air breathes out from the darkness beyond. This is the mouth of a cave. And you're about to enter a place where time moves differently than anywhere you've ever been. Step inside. Feel the temperature drop around your shoulders. The sunlight fades behind you until only your flashlight cuts through the darkness ahead. With each step deeper into the earth, you're moving closer to something remarkable. You're entering a realm where gravity's touch on time becomes stronger. Where each second stretches just a little longer than the seconds you know above ground. The cave around you was carved by water over millions of years. Drop by drop, underground streams dissolved limestone and sandstone. They hollowed out chambers and tunnels that reached deep into the planet's body. Some of these caves stretch down for miles. They create spaces closer to Earth's center than almost anywhere else you could safely visit. And the closer you get to Earth's center, the slower time moves. The walls around you hold this secret. Every stalactite hanging from the ceiling, every stalagmite rising from the floor, exists in time that flows more slowly than the time in your bedroom above. This isn't a story or a dream. It's measurable reality. Scientists have carried atomic clocks into the deepest caves on Earth. These clocks are so precise they can detect changes in time smaller than a human lifetime. When brought back to the surface, these clocks show they've been running slow. Not slow because they're broken. Slow because time itself moved more slowly in the depths. Picture a cave explorer spending a week underground. She carries food, water, and the most accurate watch ever made. She maps passages and studies underground rivers. She sleeps in chambers that have never seen sunlight. When she emerges, her watch reads slightly behind the clocks on the surface. The difference is tiny. Measured in nanoseconds. But it's real. During her week underground, she experienced fractionally less time than her friends above. She aged microseconds less than she would have at sea level. The cave held her in slower time, the way amber holds ancient insects. Gently. Protectively. Almost imperceptibly. Think about what this means. Deep beneath your feet right now, in caverns you'll never see, time is flowing at a different rate. Cave fish swim through slower seconds. Underground streams flow through elongated moments. The deepest caves on Earth reach down nearly 2 miles below the surface. In these depths, the difference in time's flow becomes more noticeable. Still incredibly small by human standards, but measurable by our most sensitive instruments. Mammoth Cave in Kentucky stretches for hundreds of miles underground. Its deepest passages sit far below the rolling hills above. Tour guides lead visitors through chambers where time moves just a fraction slower than surface time. The tourists don't feel this difference. Their hearts beat normally. Their conversations flow at normal speed. But the atomic structure of reality around them vibrates to a slightly different temporal rhythm. Carlsbad Caverns in New Mexico plunges even deeper. Its famous big room sits 750 feet below ground. The elevator that carries visitors down is also carrying them into subtly slower time. Every elevator ride into a deep cave is a journey through time as well as space. But the most extreme caves are harder to reach. In Georgia, Krubra Cave drops more than 7,000 feet into the earth. Cave divers and expert climbers spend weeks exploring its depths. In the deepest chambers of Krubra, time moves measurably slower than at sea level. The explorers who reach these depths experience the strongest gravitational time dilation available on Earth's surface. They return to tell stories of underground waterfalls and crystal formations. But they also return having lived through slightly less time than the people who stayed above. Underground rivers create their own time effects. Water flowing deep beneath the surface moves through time zones invisible to surface dwellers. A stream might begin in faster time near the cave entrance and flow towards slower time in the depths. The fish in these streams live their entire lives in temporal gradients. They spawn and feed and die in time that flows differently from pool to pool. Cave systems near the ocean floor experience even stronger effects. Underwater caves in places like the blue holes of Belize reach depths where the combined effects of Earth's mass and water pressure create the slowest natural time on our planet's accessible surface. Divers who explore these underwater caverns descend through layers of increasingly slow time. Each meter deeper takes them further from normal temporal flow. But you don't need to become a cave explorer to connect with this reality. Every basement, every subway tunnel, every underground parking garage is a small step into slower time. The difference is far too small to matter in daily life. But it connects you to the same physics that governs the deepest caves and the most distant stars. When you walk downstairs into a basement, you're following the same path that cave explorers take into the Earth's depths. You're moving closer to the center of mass that shapes time's flow around you. Ancient cultures often felt something special about caves. They painted on cave walls. They buried their dead in cave chambers. They told stories of caves as doorways to other worlds. Perhaps they sensed something true. Caves are doorways to different time. Places where the normal flow of moments changes subtly but measurably. The darkness of caves hides more than just the absence of light. It hides a different relationship with time itself. As you lie here in the surface world, imagine the cave systems beneath you. Miles of passages where time flows to its own ancient rhythm. Chambers where seconds stretch slightly longer than the seconds ticking in your room. Underground streams flowing through temporal gradients you can't see. Cave formations growing in time that moves differently than the time that shapes your dreams. The earth beneath your pillow holds chambers where explorers have walked through measurably slower time. Where scientists have proven that Einstein's predictions about gravity and time are quietly working in the darkness below. Tonight, as you rest on the surface, your body moves through time at one rate while cave systems below experience their own subtly different rhythm. You exist in layers of time, stacked like the layers of rock that form the world beneath your feet. But the Earth's influence on time isn't limited to what lies below. Above your head, the same physics creates different effects as distance from our planet's center increases. Take a moment to feel your body as it rests. From the top of your head to the tips of your toes. You might think of yourself as experiencing one single flow of time. But something beautiful and strange is happening. Your body is a time machine. Not the kind from science fiction stories. Something far more subtle and real. Right now, your head is experiencing time slightly faster than your feet. The difference is so small that no human sense could ever detect it. But it's there. Constant. Measurable. As real as your heartbeat. Think about where your head is compared to your feet. If you're lying down, your head might be 6 feet farther from the center of the earth than your toes. If you're tall, maybe 6.5 feet. This small difference in distance creates a tiny difference in gravity's pull. Your feet feel slightly stronger gravity than your head. And where gravity is stronger, time moves slower. So your feet exist in time that flows just a fraction slower than the time your head experiences. Every breath you take happens across this gentle gradient of time. Air flows from your nose, which exists in slightly faster time, down to your lungs, which exist in slightly slower time. Your heart pumps blood from chambers that experience subtly different rates of temporal flow. Blood travels up to your brain through microscopic changes in time's rhythm. The neurons firing in your head right now are happening in time that moves infinitesimally faster than the neurons in your spinal cord. Your thoughts flow through gradients of time so gentle they feel like one smooth current. But they're not quite one current. They're a symphony of slightly different temporal rhythms, all playing together to create the music of your consciousness. Scientists have measured this effect using the most precise instruments ever created. Atomic clocks so accurate they can detect time differences smaller than a billionth of a second. When they place one clock at head height and another at foot level, the difference appears. Small beyond imagination, but real. The clock at head height runs faster. The clock at foot level runs slower. Your body spans this difference every moment you're alive. Think about what this means. When you stand up, your head moves into slightly faster time. When you lie down, different parts of your body settle into their own subtle temporal zones. When you reach up to touch something on a high shelf, your hand briefly enters faster time than your feet. When you crouch down to tie your shoes, your head temporarily slows down to match the rhythm your feet always knew. You are constantly moving through layers of time so thin they're like layers of silk. Each one barely different from the next, but different nonetheless. Your DNA exists across these layers. The genes in the cells of your scalp experience time at one rate. The genes in the cells of your feet experience time at another. The difference is vanishingly small, but it's woven into the fabric of your existence. Plants experience this same effect. A tall tree has roots that exist in slower time than its highest leaves. The sap flowing from root to crown travels through a gradient of temporal flow. Sequoia trees, some of the tallest living things on Earth, span larger time differences than your body ever could. Their roots drink from slower seconds while their crowns dance in faster moments. But even flowers in your garden participate in this cosmic dance. The petals reach toward slightly faster time while the roots anchor into slightly slower time. Buildings experience these effects too. The foundation of a skyscraper exists in slower time than its roof. Elevators carry people through measurable changes in temporal flow as they rise and fall. The tallest buildings on Earth create time differences large enough that sensitive clocks can detect them. Workers on the top floors age microseconds faster than workers in the basement. But your body remains the most personal example of this physics. You carry your own private time machine wherever you go. When you walk upstairs, every step carries you into slightly faster time. When you walk downstairs, every step takes you into slightly slower time. Your body adjusts without you ever noticing. Your inner ear, which helps you balance, works across these subtle time differences. Your spine connects faster time consciousness to slower time legs. Your nervous system coordinates signals that travel through microscopic temporal gradients. Even when you sleep, this dance continues. Your dreams unfold across layers of time. The thoughts forming in your head happen in time that flows just a fraction faster than the circulation in your feet. Blood returning from your toes to your heart travels through an almost imperceptible time gradient. Every heartbeat pumps life through this gentle temporal landscape. This is one of the most beautiful aspects of Einstein's universe. Time isn't separate from life. It's woven into every cell, every breath, every thought. You don't just exist in time. You exist across time. Your body spans multiple rates of temporal flow, all coordinated into the single experience of being you. The consciousness reading these words right now is happening in the faster time of your head. But that consciousness depends on a body that reaches down into slower time. You are a bridge between different flows of time. A living connection between the faster seconds of height and the slower seconds of depth. This happens whether you're awake or asleep. Whether you're thinking or dreaming. Whether you're moving or perfectly still. Right now, as you rest, you're experiencing one of the most profound effects Einstein ever predicted. Your own body is proving that time is not uniform. That it flows differently in different places. You are your own experiment in the nature of spacetime. The atoms in your head vibrate to a rhythm slightly faster than the atoms in your feet. This difference is written into the quantum structure of your existence. Tomorrow, when you stand up and walk around, you'll be moving through time as well as space. Taking your personal time machine with you wherever you go. Tonight, though, as sleep finds you, let your consciousness rest in the knowledge that you exist across multiple streams of time, all flowing together to create the gentle river of your dreams. But there are places where scientists have built even more sensitive instruments to measure time's variations. Places where the universe's most precise clocks reveal secrets that would amaze you. In laboratories around the world, in rooms kept perfectly still and quiet, there are clocks that keep time better than anything nature has ever created. These are not the clocks on your wall or the watch on your wrist. These are atomic clocks. And they listen to the heartbeat of atoms themselves. Picture the smallest pieces of matter you can imagine. Atoms so tiny that millions could fit on the period at the end of this sentence. Inside each atom, electrons dance around the center in patterns older than Earth itself. These electrons move between energy levels like musicians changing notes. When they jump from one level to another, they create vibrations. Perfect, unchanging vibrations that repeat billions of times each second. Scientists have learned to listen to these atomic songs. They've built machines that count each vibration, using them as the ticks of the most precise clocks ever made. An atomic clock is so accurate that it would lose less than 1 second if it ran for 30 million years. It makes your heartbeat seem wildly irregular. It makes the spinning of Earth look sloppy and uneven. But these perfect timekeepers have revealed something unexpected. When you move them to different places, they disagree with each other. Not because they're broken. Because time itself flows differently in different places. In the 1970s, scientists loaded atomic clocks onto airplanes and flew them around the world. When the planes landed, the traveling clocks showed different times than identical clocks that had stayed on the ground. The differences were tiny, measured in billionths of a second. But they matched Einstein's predictions exactly. The clocks that flew east, moving with Earth's rotation, ran slower. The clocks that flew west, moving against the rotation, ran faster. Motion through space had changed the flow of time itself. But the most revealing experiments happened when scientists carried atomic clocks up mountains and down into valleys. Picture a team of researchers hiking up a tall mountain, carrying one of these precision timepieces in a careful pack. With each step higher, they're moving farther from Earth's center. Farther from the source of gravity that slows time. At the mountain's peak, they compare their clock to an identical one that stayed at sea level. The mountain clock is running faster. Not by much, but faster. Time flows more quickly where gravity is weaker. The same experiment works in reverse. Carry an atomic clock down into a deep mine, and it starts running slower than clocks on the surface. The stronger gravity of being closer to Earth's center makes each second stretch just a little longer. These discoveries prove that your everyday experience of time is shaped by where you are. The time you feel as natural and constant is actually the specific rhythm created by Earth's gravity at sea level. Move up or down, and you enter different streams of time. The most sensitive atomic clocks can detect height changes as small as a single step on a staircase. Carry one upstairs, and it speeds up. Bring it back down, and it slows down. Your house exists in layers of time, each floor experiencing its own subtle temporal rhythm. Scientists have used this effect to measure the shape of Earth itself. By comparing atomic clocks at different locations, they can map the tiny variations in gravity across the planet's surface. Places where underground rock is denser create slightly stronger gravity. Time moves fractionally slower there. Places where the rock is less dense create weaker gravity. Time moves fractionally faster. The atomic clocks reveal a hidden landscape of time flows, painted across the surface of our world in differences too small for human senses to detect. In Boulder, Colorado, scientists operate atomic clocks so precise they can measure the time difference between your head and your feet. These instruments detect gravitational time dilation across distances smaller than your body's height. They've confirmed that you really do live across multiple streams of time, just as Einstein predicted. The most advanced atomic clocks use lasers to trap individual atoms in webs of light. These captive atoms vibrate in perfect isolation, unaffected by temperature or pressure or magnetic fields. Their vibrations create time standards more stable than anything in the natural world. More regular than the pulse of distant stars. More consistent than the orbit of planets. Yet even these perfect timekeepers reveal time's flexibility when moved through Earth's gravitational field. Today, atomic clocks help guide spacecraft across the solar system. They synchronize the internet that connects computers around the world. They make possible the GPS satellites that know exactly where you are on Earth. All of these technologies depend on understanding how gravity shapes time. Without atomic clocks to measure these effects, our modern world would lose its precision. But atomic clocks have revealed more than just practical applications. They've shown us that time is not the unchanging background we thought it was. Time is woven into the fabric of space itself. It bends with gravity. It flows like a river that speeds up and slows down depending on the landscape it moves through. Every atomic clock is a window into this deeper reality. Each tick is a measurement of how the universe actually works, beneath the smooth surface of everyday experience. As you rest tonight, atomic clocks around the world are ticking in their quiet laboratories. Some are running slightly faster than others, depending on their height above sea level. Some are carried in airplanes, measuring time's flow as they cross time zones. Others sit in underground facilities, counting seconds that pass more slowly than the seconds in your room. These mechanical listeners to atomic songs are revealing the universe's most intimate secrets about the nature of time itself. The vibrations they count are the same vibrations that happen in every atom of your body. The same quantum rhythms that pulse through the air you breathe and the ground beneath you. You are surrounded by the raw material of atomic time. Every breath contains billions of atoms vibrating to the universe's fundamental frequencies. But some of these precision timekeepers have traveled much farther than mountain peaks or deep mines. Some orbit high above your head, measuring time in the emptiness of space. Right now, as you rest in the quiet of your room, something remarkable is happening 12,000 miles above your head. Metal birds the size of cars are dancing in slow circles around the Earth. They have no wings, no feathers. But they fly in perfect formation through the emptiness of space. These are GPS satellites. And they're having a conversation with time itself. Each satellite carries atomic clocks as precise as any ever built. For clocks per satellite, all counting the vibrations of atoms with incredible accuracy. But something strange happens to these clocks as they orbit far above the atmosphere. They start running fast. Faster than identical clocks on the ground below. The difference isn't small. Without correction, these satellite clocks would gain about 38 microseconds every single day. That might sound tiny, but in the world of precise navigation, it's enormous. If these clocks ran fast for just one day without correction, your GPS would think you were miles away from where you actually are. After a week, it would lose track of you entirely. So every day, thousands of times per day, engineers send signals to these orbiting timepieces. Slow down, they tell the clocks. You're running too fast. The satellites obey. They adjust their timing to match the slower rhythm of earthbound time. This daily dance between ground and sky is one of the most practical applications of Einstein's insights about gravity and time. The satellites experience weaker gravity than you do. They orbit at heights where Earth's pull is gentler, more distant. In this reduced gravity, time flows faster. Picture time as a river flowing past the Earth. Close to the planet's surface, where gravity is strong, the river moves slowly. Far above, where gravity weakens, the river speeds up. The satellites swim in the faster current. You rest in the slower one. But there's another effect at work too. The satellites are moving fast. Really fast. They complete an orbit around Earth twice each day, traveling at about 8,700 miles per hour. This motion creates its own influence on time. The faster something moves, the slower time passes for it. This is another part of Einstein's universe, working alongside gravitational effects. So the satellites experience two competing influences on time. Their height makes time run faster. Their speed makes time run slower. The height effect wins. The faster flow of time in weaker gravity is stronger than the slowing effect of their orbital speed. The result is that satellite time runs faster than ground time by about 38 microseconds per day. Engineers discovered this effect when they first launched GPS satellites in the 1970s. The system didn't work as expected. Navigation was wildly inaccurate. At first, some scientists wondered if Einstein's theories were wrong. But careful analysis revealed the truth. The theories were perfectly correct. Time really was flowing faster in orbit. Once engineers programmed the satellites to account for this time difference, GPS became the marvel of precision we know today. Your phone can pinpoint your location to within a few feet anywhere on Earth. This accuracy depends entirely on accounting for the different flow of time between satellites and ground. The satellites send time-stamped signals to your device. By comparing signals from multiple satellites, your phone calculates exactly where you are. But this calculation only works if the satellite clocks and your phone's clock are perfectly synchronized, accounting for the faster flow of time in orbit. Every time you check your location, you're using Einstein's insights about gravity and time. There are 31 GPS satellites currently dancing above you. Each one carries multiple atomic clocks. Each clock is constantly adjusted to account for the faster flow of time at orbital height. But GPS isn't the only satellite system that deals with time effects. Communication satellites, weather satellites, and scientific instruments in orbit all experience the same temporal acceleration. The International Space Station orbits much lower than GPS satellites, only about 250 miles above Earth. At this height, the time effects are different but still measurable. Astronauts living on the station experience time that flows slightly faster than your time on the ground. Not by much, but enough that precision instruments can detect it. When astronauts return to Earth after months in orbit, they've aged microseconds more than they would have if they'd stayed on the surface. The Hubble Space Telescope, floating in its orbit above the atmosphere, keeps time differently than telescopes on mountaintops. Its instruments must account for the faster temporal flow of its orbital environment. Even the Moon experiences time differently than Earth. Its weaker gravity means that time flows faster on the lunar surface than it does in your bedroom. Future Moon bases will need to coordinate their clocks with Earth time, accounting for this difference. Lunar colonists will live in a slightly accelerated temporal flow. The farther you travel from Earth, the faster time moves relative to our planet's surface. Mars experiences faster time than Earth. Jupiter experiences faster time than Mars. Throughout the solar system, different worlds dance to different temporal rhythms, all shaped by their gravitational environments. But you don't need to travel to space to connect with these effects. Every airplane flight carries you briefly into faster time. Commercial jets cruise at heights where gravity is slightly weaker than at sea level. The difference is small, but real. When you fly across the country, you experience a tiny taste of what satellites feel constantly. Your watch doesn't run fast during the flight because it's mechanical, not atomic. But atomic clocks on airplanes do detect the faster flow of time at cruising altitude. Weather balloons carrying scientific instruments float even higher, where time effects become more noticeable. These high-altitude laboratories drift through temporal flows that bridge the gap between ground time and satellite time. The atmosphere itself exists across gradients of time. Air at different altitudes experiences subtly different temporal rhythms. Birds flying at various heights move through these time gradients without knowing it. Their migration patterns unfold across layers of slightly different temporal flow. As you lie here tonight, the satellites continue their endless dance above you. Their atomic clocks tick in the faster time of orbital space while your heart beats in the slower time of Earth's surface. The signals they send down to your devices carry timestamps from a different temporal realm. Messages from the sky, speaking in the accelerated language of weakened gravity. But there are places on Earth where gravity creates even more dramatic effects on time's flow than the heights of satellite orbits. Imagine diving deeper than any human has ever gone. Past the last glimpse of sunlight filtering through blue water. Past the deepest swimming whales. Past the reach of storms and waves. You're descending toward the bottom of the world. 7 miles down, where the ocean floor drops into trenches so deep they could swallow entire mountain ranges. Here, in the deepest places on Earth, time flows differently than anywhere else you could visit. The Mariana Trench stretches across the Pacific Ocean floor like a scar in the planet's skin. Its deepest point, called Challenger Deep, plunges nearly 7 miles below the surface of the sea. If Mount Everest were placed in this trench, its peak would still be more than a mile underwater. In these crushing depths, time moves more slowly than it does in your room tonight. The weight of 7 miles of water presses down with incredible force. But beneath that water lies something even more significant. The seafloor here sits closer to Earth's center than almost anywhere else on the planet's surface. This closeness to Earth's core creates the strongest gravitational pull you can experience without leaving the surface world behind. And where gravity is strongest, time moves slowest. Picture time as honey flowing through the deep ocean. Near the surface, where you might swim on a summer day, the honey flows freely. But down in the trenches, the honey thickens. Each second stretches just a little longer. The difference is tiny beyond imagination. But it's real. Measurable. Written into the fabric of existence itself. Deep-sea creatures live their entire lives in this slower time. They've never known the slightly faster seconds that flow in shallow water or on dry land. Giant tube worms cluster around volcanic vents on the ocean floor, growing in time that moves more slowly than the time that shapes coral reefs above. Their cells divide, their lives unfold, their generations pass in the slowest natural time on Earth's surface. Barrel-eye fish drift through these depths with their transparent heads and upward-facing eyes. They hunt and mate and die in temporal rhythms subtly different from their cousins in shallower seas. The anglerfish that carry their own lights through the eternal darkness experience every moment of their mysterious lives in time that flows just fractionally slower than surface time. These creatures don't know they live in slower time. To them, their seconds feel normal. Their heartbeats, their movements, their thoughts all follow the rhythm they've always known. But if you could somehow transport them instantly to shallow water, their internal clocks would be slightly out of sync with the faster time flow above. The deepest parts of these trenches have been visited by only a handful of humans. In 1960, Jacques Piccard and Don Walsh descended to Challenger Deep in a thick-walled sphere called the Trieste. They spent 20 minutes on the bottom of the world, looking out small windows at a landscape no human eyes had ever seen. During those 20 minutes, they experienced the slowest time accessible to human visitors on Earth. When they returned to the surface, they had lived through slightly fewer moments than identical twins who stayed at sea level. The difference was unimaginably small, but real. More recently, filmmaker James Cameron made a solo dive to the bottom of Challenger Deep. He spent hours exploring the deepest place on Earth, collecting samples and filming the alien landscape. During his time in the abyss, he experienced the most extreme gravitational time dilation available without leaving the planet. His cameras recorded images from the realm of slowest time. But ocean trenches aren't the only deep places where time flows slowly. Underground rivers and caves extend even deeper into Earth's crust, though they're harder to reach than the ocean floor. The deepest mines on Earth reach down more than 2 miles below the surface. Gold miners working at these depths experience slightly slower time than miners working in shallow pits. South African gold mines extend deeper into the planet than anywhere else humans regularly work. The miners who ride elevators down these shafts are traveling into progressively slower time with each foot of descent. At the bottom of the deepest mines, time flows more slowly than it does in most ocean trenches. The combination of depth and proximity to Earth's dense core creates the most extreme time dilation available to surface dwellers. But accessing these depths requires enormous effort and expense. The ocean trenches, while still incredibly difficult to reach, offer the most accessible experience of Earth's slowest time. The pressure at the bottom of Challenger Deep is more than 1,000 times greater than the pressure you feel right now. It would crush most materials instantly. But it can't crush time itself. Time flows according to its own laws, shaped by the curvature of space created by Earth's mass. The crushing pressure is a result of gravity. The slower time is also a result of gravity. Both effects spring from the same source, the planet's enormous mass pulling everything toward its center. Water at the bottom of ocean trenches is ancient. Some of it has been trapped in the deepest places for thousands of years, cycling slowly through the abyss. This ancient water flows through the slowest time on Earth's surface. The salts dissolved in deep ocean water have existed in slower time for millennia. Every molecule, every atom, every electron has been shaped by the subtle time dilation of the depths. Even the rocks forming the trench walls exist in this slower temporal flow. The minerals crystallized, the sediment settled, the geological processes unfolded in time that moves differently than surface time. The entire deep ocean environment is a realm apart from the surface world you know. Not just in terms of pressure and temperature and light, but in terms of time itself. Whales diving to great depths experience brief tastes of this slower time. Sperm whales, hunting giant squid in the deep, spend parts of their lives in temporal flows that differ from surface waters. Their songs, traveling through layers of water at different depths, cross gradients of time as they echo through the ocean. Sound waves moving from deep water to shallow water travel between subtly different temporal realms. The boundary between surface and deep ocean is also a boundary between slightly different flows of time. Research submarines exploring these depths carry atomic clocks that can detect the time difference. When they return to the surface, their precision instruments confirm what Einstein predicted about gravity and time. As you rest tonight, these deepest places continue their ancient existence in the slowest time Earth can offer. 7 miles below the ocean surface, in trenches that have never known sunlight, time flows to its own patient rhythm. The abyss holds its secrets in water that moves through seconds stretched just a little longer than the seconds that surround your dreams. But there are people who regularly travel between these different flows of time, experiencing the subtle shifts as they move from deep places to high places and back again. Every morning, somewhere in the world, a miner steps into an elevator that will carry him deep into the earth. Every day, somewhere else, a mountain climber laces up her boots and begins the long journey toward a distant peak. These two people are about to experience opposite effects on the flow of time itself. The miner descends. With each foot deeper, he moves into slightly slower time. The mountain climber ascends. With each foot higher, she moves into slightly faster time. Neither feels the change. Their hearts beat normally. Their thoughts flow at familiar speeds. But the universe around them shifts its temporal rhythm with every step they take. Picture the miner first. His elevator drops through layers of rock that have been undisturbed for millions of years. Past underground rivers and pockets of ancient air. Past the reach of seasons and weather. He's traveling toward Earth's core, where gravity grows stronger and time moves slower. In South Africa's deepest gold mines, miners work more than 2 miles below the surface. The elevator ride down takes nearly 10 minutes. During those 10 minutes, the miners are traveling through gradients of time. At the surface, before the shift begins, their watches tick in rhythm with surface time. But as the elevator drops, they enter progressively slower temporal flow. By the time they reach the bottom, they're working in time that moves fractionally slower than the time their families experience above ground. The difference is tiny. Over an entire working lifetime, a deep miner might age microseconds less than someone who never went underground. But the effect is real and measurable. The rock around these miners formed in slower time. The gold they extract has spent eons in temporal flow that differs from surface time. Every nugget they bring to the surface is a piece of deep earth time. The air they breathe has been trapped in slower time for ages. The water that seeps through the rock walls has flowed through these temporal depths for centuries. Now picture the mountain climber beginning her ascent. She starts at sea level, where time flows at the rate you know as normal. But with each step up the trail, she moves farther from Earth's center. Gravity's pull weakens, almost imperceptibly. And where gravity weakens, time flows faster. The difference is so small that no human could ever feel it. But it's there, written into the fabric of space and time around her. As she climbs higher, past tree line and into thin air, she enters the realm of faster time. Her body doesn't know it, but she's experiencing time that flows slightly quicker than the time in valleys below. Professional mountain climbers who spend weeks at high altitude live in this accelerated temporal flow. Their cells divide, their hearts beat, their thoughts form in time that moves fractionally faster than sea level time. Climbers on Mount Everest experience the most extreme version of this effect available through mountain climbing. At 29,000 feet, they exist in time that flows measurably faster than time at sea level. The air they struggle to breathe is thin because it exists in weaker gravity. The same weak gravity that makes their time flow faster also makes the atmosphere less dense. Every breath at high altitude happens in slightly accelerated time. The most dramatic example comes from comparing these two extremes. Imagine a deep miner working 2 miles underground while a mountain climber scales a peak for miles above sea level. The vertical distance between them is 6 miles. This creates a measurable difference in the flow of time. If they both carried atomic clocks, the clocks would show different times after just a single day. The mountain climber's clock would run ahead of the miner's clock by about 20 nanoseconds. That's an incredibly small amount. 20 billionths of a second. But it's real and detectable. Over a year, this difference would grow. The mountain clinker would age microseconds more than the deep miner, simply due to their different positions in Earth's gravitational field. Commercial airline pilots experience a milder version of the mountain climber effect. They spend their careers at altitudes where time flows faster than ground time. Over decades of flying, pilots age slightly more than people who stay at sea level. The difference is microscopic but measurable with precision instruments. Flight attendants, air traffic controllers, and frequent business travelers all participate in this gentle acceleration of time. But miners experience the opposite. Coal miners, diamond miners, workers in underground tunnels and subway systems all spend their days in slightly slower time. The deepest subway systems in the world, like those in Moscow and Kiev, carry passengers through measurable time dilation effects. The ride from surface to platform is a journey through subtle changes in temporal flow. Underground cities, like the vast complexes in Montreal and Helsinki, exist in time that flows slightly slower than the surface cities above them. But most people who work underground don't venture as deep as gold miners. Office workers in basement levels experience only tiny effects. The difference between basement time and penthouse time in a typical building is far too small to matter. Still, the physics is there. Every floor of every building exists in its own subtle temporal rhythm. Elevator operators, who spend their careers traveling up and down through these microgradients of time, experience constant tiny shifts in temporal flow. Their bodies move through layers of time as regularly as they move between floors. The most extreme human experiences of time dilation come from combining horizontal and vertical movement. Airplane flights from sea-level airports to high-altitude destinations create complex time effects. A pilot flying from Los Angeles to Denver experiences time dilation from both the altitude of flight and the elevation difference between airports. The plane climbs through layers of increasingly fast time, then lands at an airport where ground time flows faster than Los Angeles ground time. Satellite repair missions create even more dramatic effects. Astronauts who travel from Earth's surface to orbital altitudes experience the most extreme time dilation available to human beings. They launch from slower surface time and arrive in the faster time of orbital space. When they return, they've lived through slightly different temporal experiences than people who stayed on the ground. But you don't need to become a miner or climber to experience these effects. Every time you ride an elevator, you travel through gradients of time. Every time you climb stairs, you move toward faster time. Every time you go downstairs, you move toward slower time. Your daily vertical movements carry you through invisible layers of temporal flow. The basement of your house exists in slightly slower time than your attic. When you go downstairs to do laundry, you enter fractionally slower time. When you go upstairs to bed, you enter fractionally faster time. These changes are far too small to affect your daily life. But they connect you to the same physics that govern satellite orbits and deep mine shafts. You are always moving through time as well as space, even when you think you're standing still. Tonight, as you rest at whatever elevation you call home, miners are working in slower time deep underground while climbers sleep in faster time on distant peaks. But time's effects on daily life extend far beyond the extremes of mines and mountains, touching ordinary moments in ways you might never expect. This morning, you probably experienced time dilation without realizing it. Maybe you rode an elevator. Maybe you walked up or down stairs. Maybe you drove over a hill or through a valley. Each of these simple movements carried you through invisible changes in the flow of time itself. The magic of Einstein's universe isn't hidden in distant stars or exotic laboratories. It's woven into the fabric of your everyday life, so subtly that you never notice it's there. Consider your morning cup of coffee. You might have made it in your kitchen, then carried it upstairs to drink while getting ready for the day. That journey from kitchen to upstairs room was a journey through time as well as space. The coffee in your upstairs room existed in slightly faster time than it did in your kitchen below. The difference is unimaginably small. Your coffee didn't cool any faster. Your taste buds couldn't detect any change. But the atomic clocks that govern the universe's most precise measurements would show the difference. Your house is a gentle time machine, with each floor experiencing its own subtle temporal rhythm. When you take a shower on the second floor, water flows over your body in time that moves fractionally faster than the time in your basement. When you eat breakfast in your kitchen, you're nourishing yourself in time that flows at its own particular rate. Even your bed, where you rest right now, exists in time that flows at a slightly different rate than your neighbor's bed, if your houses sit at different elevations. The city around you is a landscape of invisible time flows. Skyscrapers reach into faster time while their foundations anchor into slower time. People working on the top floors of tall buildings age microseconds faster than people working in the basements below. The elevator that carries office workers from lobby to penthouse is a time machine, moving its passengers through gradual changes in temporal flow. In New York City, workers in the Empire State Building experience different rates of time depending on which floor they work on. The difference is tiny, but real. The building spans enough height to create measurable time dilation. People eating lunch on the observation deck exist in slightly faster time than people eating lunch in the subway stations far below the street. Every elevator ride in every tall building is a journey through Einstein's universe. But elevation isn't the only way your daily life touches time dilation. Motion creates its own effects on the flow of time. When you drive your car down the highway, you're moving fast enough to experience time dilation from your speed. The effect is incredibly small, but it's there. At 60 miles per hour, time slows down for you by about 1 part in 200 trillion. This is far too small to matter in any practical way, but it connects you to the same physics that governs high-speed particles and spacecraft. Commercial airplanes create more noticeable effects. When you fly across the country, you're traveling at 500 miles per hour at an altitude of 6 miles above sea level. 2 time dilation effects work on you simultaneously. Your speed makes time run slightly slower. Your altitude makes time run slightly faster. The altitude effect wins, so you experience slightly faster time during flight. Over the course of a long flight, you age a few nanoseconds more than you would have if you'd stayed on the ground. The difference is unmeasurable by human standards, but it's real. Frequent flyers, airline crews, and pilots accumulate these tiny time differences over their careers. They live slightly more accelerated lives than people who never leave the ground. But you don't need to fly to experience motion-based time dilation. Every car ride, every bicycle trip, every walk down the street involves movement through space that creates microscopic changes in time's flow. The faster you move, the more time slows down around you. Even walking creates this effect, though it's far too small to detect without atomic clocks. Your daily commute is a journey through subtle changes in both gravitational and motion-based time dilation. If you take a train to work, you experience the time effects of both your motion and the elevation changes along the route. Trains climbing hills carry passengers into faster time. Trains descending into valleys carry passengers into slower time. Subway systems create their own time environments. Underground trains move through slower time created by being below ground level. But they also move through the motion-based time effects of their speed. The New York subway system, the London Underground, the Paris Metro all create invisible networks of time flows beneath their cities. Even walking through your neighborhood involves constant tiny changes in time's rhythm. Every hill you climb moves you toward faster time. Every valley you descend moves you toward slower time. The difference is far too small to affect your experience, but it's part of the invisible physics that governs every step you take. Your smartphone's GPS knows about these time effects. The satellites it connects to experience faster time due to their orbital altitude. The GPS system must constantly correct for this time difference to give you accurate location information. Every time you check your position on a map, you're depending on technology that accounts for Einstein's insights about time and gravity. The cell phone towers that carry your calls exist at different elevations. Towers on hilltops experience slightly faster time than towers in valleys. Your phone calls travel through networks that span subtle gradients of time flow. Even the internet relies on precise timing that must account for relativistic effects. Data centers, servers, and communication networks all participate in the complex dance of keeping synchronized time across a world where time flows differently in different places. The electrical grid that powers your home operates on timing so precise that engineers must consider relativistic effects. Power plants at different elevations experience subtly different time flows, but the electrical system must stay perfectly synchronized. Water flowing through pipes in your house moves from higher to lower elevations, traveling through microscopic gradients of time flow. The water coming from your faucet has journeyed through invisible layers of temporal variation. Even the foundation of your house experiences slightly slower time than your roof. The concrete, the wooden beams, the insulation all exist across subtle gradients of time flow. Your morning routine unfolds across these invisible time effects. Brushing your teeth upstairs happens in slightly faster time than making breakfast downstairs. Taking out trash to the curb involves moving through tiny changes in temporal flow. The ordinary becomes extraordinary when you realize that every mundane activity connects you to the deepest truths about space, time, and gravity. You live in Einstein's universe every moment of every day. The effects are too small to change your experience, but they're real enough to be measured by our most sensitive instruments. Tonight, as you settle into sleep, you're experiencing time dilation from your elevation, your motion through space as Earth rotates, and the gravitational field that surrounds you. Your dreams will unfold in time that flows at rates determined by your exact position in the universe's fabric of spacetime. But beyond these everyday encounters with time's flexibility, there are deeper questions that scientists are still exploring about the nature of time itself. In laboratories around the world tonight, scientists are lying awake thinking about time. Not because they're worried or anxious, but because the questions about time are so beautiful they're hard to let go of. What if twins were separated at birth, and one lived her entire life in a deep cave while the other lived on a mountaintop? After 80 years, would they be the same age? The answer is no. The underground twin would be microseconds younger. Not enough to matter in human terms, but enough to reveal something profound about the nature of existence itself. This thought experiment has led scientists to ask even stranger questions. What if we built a city at the bottom of the ocean? Would the people living there age differently than people living in cities on dry land? What if we hollowed out the inside of a mountain and created a community there? Would children born and raised in that environment experience time differently than children born at sea level? These aren't just idle wonderings. They're questions that help scientists understand the fundamental nature of time and space. Some researchers have proposed building underground laboratories that would run for generations. Not just for a few years, but for decades or centuries. They want to study how long-term exposure to different gravitational time flows might affect living things. Would plants grow differently in slower time? Would animals live longer or shorter lives? Would human biology adapt to the subtle changes in temporal flow? The questions multiply like ripples in a pond. If you spent your pregnancy in a deep cave, would your baby develop at a slightly different rate than babies developing at sea level? The difference would be unimaginably small, but it would be real. Would the baby's first heartbeat happen in slower time? Would their first breath fill lungs that had formed in a subtly different temporal environment? Scientists wonder about the long-term effects of living in different time flows. If a family lived for generations in slower time, would their descendants be measurably different from families that lived in faster time? Evolution happens over thousands and millions of years. Could time dilation effects, accumulated over such vast periods, influence how life develops? These questions lead to experiments that sound like science fiction but are grounded in real physics. Researchers have placed atomic clocks in underground bunkers and left them running for months. They've flown clocks around the world in airplanes and measured the tiny time differences created by motion and altitude. They've synchronized clocks at the top and bottom of tall towers, then watched as the clocks slowly drift apart due to gravitational time dilation. Each experiment reveals new details about how time flows differently in different places. But some of the most intriguing questions can't be answered with today's technology. They require experiments that would take lifetimes to complete. What would happen to your sense of time if you lived your entire life in a place where clocks run slower? Would you instinctively feel that something was different? Or would the slower rhythm feel completely normal to you? Your body has its own internal clocks. Your heartbeat, your breathing, your sleep cycles, the rhythms of your brain waves. All of these biological processes happen at rates determined by the chemistry and physics of your cells. But what if those cells developed and lived their entire existence in slower time? Would your internal rhythms adjust to match the external time flow? Scientists have discovered that even bacteria respond to time dilation effects. In experiments with extremely precise measurements, bacterial colonies growing in slightly slower time show subtly different patterns of reproduction and growth. If microscopic life responds to time dilation, what about complex organisms like humans? These questions have practical implications too. As humans begin to establish permanent settlements in space, on the moon, or on other planets, we'll be creating communities that exist in different gravitational time flows. Children born on the moon will grow up in time that flows slightly faster than Earth time. Children born on Mars will experience time that flows at its own unique rate, different from both Earth and Moon time. Will these children develop differently? Will their biological clocks adapt to their local time flows? Will they feel out of sync when they visit other worlds? Some scientists wonder about even more extreme scenarios. What if we could create artificial gravity fields that are much stronger than Earth's gravity? What would it be like to live in drastically slower time? Could humans adapt to time that flows significantly slower than what we're used to? Or would such extreme time dilation create biological problems we can't predict? These questions push the boundaries of what we can study with current technology. But they point toward future experiments that might be possible as our understanding of gravity and time grows deeper. Meanwhile, other researchers focus on questions we can explore today. Does time dilation affect memory formation? When you create memories in slower time, do they feel different from memories created in faster time? Does it affect learning? If you spent a year studying in a deep underground laboratory, would you learn at a different rate than someone studying at sea level? The differences would be incredibly small, but they might be measurable with sensitive enough instruments. Some of the most beautiful questions are the ones that have no immediate practical applications. They exist purely to satisfy human curiosity about the nature of reality. If you could somehow perceive time dilation directly, what would it feel like? Would slower time feel thick and syrupy? Would faster time feel light and quick? Or would you never notice the difference, because your perception of time would adjust to whatever rate you were experiencing? These questions remind us that our everyday experience of time is just one possible way of experiencing temporal flow. The universe offers countless other rhythms, other tempos, other ways that moments can unfold. Scientists stay awake thinking about these mysteries not because they need to solve them immediately, but because they reveal how much we still don't understand about the cosmos we live in. Every answer leads to new questions. Every experiment reveals new mysteries. The more we learn about time dilation, the more we realize how much more there is to discover. Tonight, as you prepare for sleep, scientists around the world are designing experiments that won't be completed for decades. They're asking questions that might take generations to answer. But some of the most profound truths about time are already clear, waiting to accompany you into your dreams. Tonight, as sleep begins to find you, time is your most faithful companion. It has been with you since your first breath. It will stay with you through your last. But now you know something beautiful about this companion that you didn't know before. Time is not the rigid, unchanging presence you once thought it was. Time is gentle, flexible, responsive to your presence in the world. Right now, as you rest, time flows around your body like water around a stone in a stream. Your mass, tiny as it is compared to planets and stars, still creates the smallest ripple in the fabric of space-time. You are not separate from time. You are woven into it. Every atom in your body participates in time's cosmic dance. The electrons spinning around atomic nuclei in your skin move to rhythms shaped by Earth's gravity. The molecules in your blood flow through time that bends gently around our planet's mass. Your heartbeat marks time in a rhythm that has been shaped by 4.5 billion years of Earth's gravitational embrace. Your breathing follows patterns that connect you to the same physics that governs distant galaxies. As you sink deeper into rest, your body continues its ancient conversation with time itself. The pillow beneath your head exists in time that flows fractionally faster than the time experienced by your feet. This difference is so small that no human sense could ever detect it, but it's real. It's part of the invisible poetry of existence. Your dreams tonight will unfold across these gentle gradients of time. The thoughts forming in your mind will happen in the slightly faster time of your head, while your heart pumps life through your body in the slightly slower time of your center. You are a living bridge between different streams of temporal flow. Einstein's gentle revolution has shown us that time is not a stage upon which life happens. Time is part of life itself. It bends with mass, flows with motion, dances with energy in ways that seem magical but are deeply natural. The universe you inhabit is far stranger and more wonderful than the clockwork cosmos people imagined just a century ago. It's a place where time flows like honey in some places and races like wind in others. Where satellites must constantly adjust their clocks to stay synchronized with Earth time. Where miners work in slightly slower seconds and mountain climbers breathe in slightly faster moments. Where the depths of ocean trenches hold time differently than the peaks of mountains. Where your basement and your attic exist in subtly different temporal realms. All of this happens so gently, so subtly, that life continues without noticing. But the effects are real, measurable, constant. You live in Einstein's universe every moment of every day. The time you experience as natural and steady is actually Earth time, shaped by our planet's mass and motion through space. If you lived on the moon, time would flow differently for you. If you lived on Mars, you would age at a subtly different rate. If you lived in the space between stars, far from any gravitational pull, time would race compared to the gentle rhythm you know here. But Earth time is your time. It's the rhythm that shaped your biology, your consciousness, your dreams. The calcium in your bones crystallized in Earth time. The neurons in your brain formed connections in Earth time. The memories you treasure were created in the specific temporal flow of our planet's gravitational field. You are made of Earth time as much as you are made of Earth matter. Tonight, as your consciousness begins to fade, you join the great community of sleeping Earth. Billions of people resting in the same gentle gravitational embrace, all experiencing time at the same cosmic rate. In caves far below, time moves slightly slower, but the difference is so small it would take precision instruments to detect it. In airplanes crossing overhead, time moves slightly faster, but again, the change is imperceptible to human experience. The vast majority of life on Earth shares your temporal rhythm. Trees growing in your neighborhood, birds sleeping in their nests, fish swimming in nearby streams, all moving through time at nearly the same rate you do. You are part of a planetary community unified by shared experience of time's flow. The stars you cannot see through your bedroom ceiling experience their own vastly different relationships with time. Some burn in gravitational fields so strong that time nearly stops. Others drift in space so empty that time races at rates we can barely imagine. But here, in this gentle middle ground between extremes, time flows at the perfect rate for life as we know it. Fast enough for change and growth and thought. Slow enough for stability and memory and love. Earth time is the rhythm of consciousness. The tempo of life. The beat that allows complexity and beauty to emerge from simple atoms dancing together. As sleep takes you deeper, your breathing slows to match the ancient rhythm of rest. Your heart rate drops to its nighttime pace. Your brain waves shift into the slower patterns of dream and restoration. All of these biological rhythms happen in Earth time, shaped by the gravitational field that has surrounded every living thing on our planet for billions of years. Your body knows this rhythm intimately. It was born into it, grew up with it, will age within it. Your cells divide according to clocks that tick in Earth time. Your thoughts form in neural networks that fire in Earth time patterns. You are a child of Earth's temporal embrace. Tomorrow, when you wake, you will move through your day experiencing Einstein's universe in countless subtle ways. Every elevator ride, every flight of stairs, every journey from valley to hilltop will carry you through invisible changes in time's flow. But tonight, you rest in the knowledge that time itself is your companion. Not a cold, mechanical measurement, but a warm, living aspect of the cosmos that responds to your presence and cradles your existence. The universe measures moments with infinite patience, and you are part of its eternal, gentle dance. Sleep well, knowing that time flows around you like the breath of the cosmos itself, steady and sure and infinitely kind.